That's it. I'm gonna make that direction positive. I could make it the I-hat direction, but it's a one-dimensional problem, so I can get away with just a plus there. Coordinate, so that's my coordinate axis. Oh, I guess I skipped the direction of acceleration. What's the direction of acceleration of the satellite? At this moment in time? That is correct, Lloyd. So, towards the Earth in general. So that's why my coordinate system is like that. Nothing to decompose because it's in the direction. And so I'm left with F equals ma. Or the force due to gravity is equal to the mass of the satellite times the centripetal acceleration. Traveling in a circle, centripetal acceleration rears its ugly head. And also, it wouldn't make sense if it didn't show up here. Substitution. Do we have an independent formula for any of these variables?
Yes.
Which one?
Yeah.
The centripetal.
I think it was said.
The centripetal acceleration.
All right, so the centripetal acceleration.
Or see it back.
So I have G, mass of Earth, mass of satellite, over r squared is equal to mass of satellite, v squared over r. Why did I choose v squared over r?
You don't have an angle.
We didn't have it. We could create an angle.
Yes, we could.
Why v squared over r makes more sense here?
Because we're looking for speed.
Yes. Yeah, that's the problem. Notice the mass of the satellite cancels out. The mass of the satellite is irrelevant. Matter of fact, r cancels out. What I'm left with is the speed of the object is g times the mass of the Earth divided by r.
Is V still squared? Yeah.
Yes, it is, v squared. And so v would be the square root of g mass of Earth over r. So g mass of Earth I'm good with. R, let's put it at 2 Earth radii away. So we'll let r be 2 radius of Earths. So now we plug in. So my speed would be the square root of 6.67 times 10 to the negative 11th times mass of the Earth, 5.98 times 10 to the 24th, divided by r, which is 2 times 6.4 times 10 to the 6th. Seems like it should be the order of 1,000 liters per second. Let's see, so. 17. About 5,000 meters a second. What you got?
5,582.24 meters per second.
Okay.
Why did you multiply the bottom by 2?
Because I said that r, the distance, was twice the Earth's radius.
Oh, okay. Sorry. Got it. Thank you.
Questions to hear?
Was there a reason you used the big R for the Earth's radius?
Yes. Did you want more? The purpose of using big R was that it was an actual value and not a variable, and that just, I needed some other letter. I didn't want to use lowercase r because I was using that as a variable.
Okay.
So I'm trying to think if there's any hard and fast rule. Seems like I usually see capital R used if it's a radius of something, it's a specific radius for something. But, yeah, I probably don't stick to that. In physics, probably the best with the lowercase uppercase is, for a number of things, uppercase means you're looking at the total, and lowercase means you're looking at the value for something individual. Like momentum, lowercase p is the momentum of one object, uppercase p is the momentum of everything. But, childhood scars, that's why. Any other questions? All right, I will stop this and talk a little bit about the test.